Hello guys, welcome back to my YouTube channel, and today we're going to be treating formation of an ordinary differential equation. So when solving for formation for an ordinary differential equation, your aim is to eliminate the constants in the equation. From example number 1, y is equals to x squared plus 2x plus c. The constant here is this c. Your aim is to eliminate this constant c. And while solving, you need to observe and know how many constants is in the equation. For like this example 1, we have only one constant, so therefore we need to differentiate once. If there is no constant in this example 1, you still have to differentiate once, but since there is one constant, we also have to differentiate once. If for example you have two constants in an equation, a plus b cos x, just you see any two constants a, b, or you have three constants. When solving, your aim is to eliminate the constants. So if you have two constants in an equation, you have to differentiate two times. If you have three constants, you have to differentiate three times. Therefore, formation of an ODE, your aim is to eliminate any constant in the equation. But example number 4, we have y is equals to ax plus a squared. We have one constant, but they appear two places in the equation, which is a. We still have to differentiate once because it is only one constant, a. Therefore, to solve this example number 1, y is equals to x squared plus 2x plus c. To solve this example number 1, we only have one constant, which is c. Therefore, we need to differentiate once. Therefore, differentiating this, we have dy over dx is equals to differentiating x squared will give us 2x, because 2 will come and multiply everything, raised to power 2 minus 1. 2 minus 1 is 1, therefore we have 2x. We no need to write the 1 is spiritual. Plus, if you differentiate 2x, you're going to have what? If you differentiate 2x, you are going to have 2. Therefore, plus 2, because this one, there is a 1 here which is spiritual. It will go and multiply everything. 1 times 2x will give us 2x, but you're going to subtract 1 from the power of x. Therefore 1 minus 1 is 0, and anything raised to power 0 is 1. Therefore, after differentiating 2, is going to have 2. Differentiating a constant will always give us zeros, so there are no need to write plus 0. Therefore, differentiating this is going to have dy over dx, which is equals to 2x plus 2. Now we have eliminated the constant. Therefore, you move everything to the other side of the equation, equating everything equals to 0. That will give you the solution to this ordinary differential equation. Therefore, you say dy over dx minus 2x. You know this 2x is positive. When it moves over to the other side, it's going to be negative. This 2 is positive. Once it moves over to the other side, it's going to be negative. Minus 2x minus 2, which is equals to 0. Therefore, this is our answer. Then, moving over to example number 2, y is equals to cos x plus c. You first of all look how many constants is in this equation. We only have one constant, which is c. Don't be confused with this cos. Whether you have any cos, tan, cosec, sec, you're not meant to focus on it. Your main focus should be on the constant. How many constants and how many times you're going to differentiate. Therefore, how many times you're going to differentiate here? You're going to differentiate once. Therefore, dy over dx is equals to differentiating cos x will give us minus sin x, because differentiating sine will give us cos. Differentiating cos will give us minus sine. Therefore, we have minus sin x. Differentiating a constant will always give us 0, so no need to write plus 0. Therefore, this is what we have. Then the answer will be dy over dx. If you move this minus sin x to the other side, no, it's negative here. Once you move out to the other side, it's going to be positive, plus sin x, which is equals to 0. Therefore, this is our answer to this. This is our solution to this ordinary differential equation. Then move over to example number 3. Example number 3, y is equals to ce to power of x. To solve this, how many constants is here? We have only one constant. Therefore, we need to differentiate once. Therefore, dy over dx is equals to differentiating c e raised to power x. You know, differentiating e to power of x will always give us the same thing as e to power of x. If you differentiate this, you're going to have this. Therefore, differentiating this is going to have ce raised to power of x. But if you look in equation 1, if you look at the equation 1, y is equals to c e to power of x. Therefore, we can say dy over dx is equals to y, because y is equals to c e to power of x. Therefore, replacing y with this in equation 2. Therefore, we now say dy over dx, this y is positive. Once it's moved over to the other side, it's going to be negative, minus y is equals to 0. Therefore, this is our solution to this ordinary differential equation.